I'm presenting the parameters of my logistic regression model. These numbers are crucial for making predictions. The intercept is -2.5, and the coefficient for monthly spending is 0.1. We'll use these values in our calculations. This is the model's starting point. It's what the model predicts when monthly spending is 0. Think of it like the base level of churn probability. This tells us how much the probability of churn changes for every dollar increase in monthly spending. A positive coefficient means higher spending is associated with a higher chance of churn. Specifically, a $1 increase raises the log odds of churning by 0.1. This equation calculates the probability of a customer churning. It uses the intercept and the coefficient, along with the customer's monthly spending, to produce a probability between 0 and 1. The equation converts a linear combination of the input features and coefficients to a probability using the sigmoid function, which ensures the probability stays within the range 0, 1. This is the main question I'm asking you to solve using the given model parameters. The statements test your understanding of how to interpret these parameters and use them for prediction. I'm setting up the problem. I'm using a logistic regression model from Sklearn to predict customer churn based solely on monthly spending. I'll be using the given parameters to evaluate the truthfulness of certain statements. I'll explain the equation. We're using a logistic regression model to predict the probability of a customer churning. The equation is probability of churn equals 1 divided by 1 plus e to the power of negative intercept plus coefficient times monthly spending. It transforms the model's output into a probability between 0 and 1. This is the mathematical representation of the equation I just explained. P, churn equals 1, means probability that churn equals 1, which is the probability a customer will churn. The express is the exponential function. The equation calculates a value based on the intercept and the coefficient of monthly spending. That value then gets plugged into the formula to generate the final probability. I'm using a logistic regression model. It's a statistical method we use for predicting the probability of a binary outcome, in this case, whether a customer will churn, leave, or not. This model uses monthly spending to make that prediction. Pretty cool, huh? This is the main question. We'll evaluate 4 statements, based on the logistic regression model and its predictions about customer churn, using the information provided. This statement presents a comparison between 2 different spending levels. The equation's answer will tell us if this is correct or not. This statement suggests a relationship between spending and churn probability. We need to analyze whether spending impacts churn probability positively or negatively. This statement focuses on a specific spending level, $100, and states that the predicted probability of churn will be greater than 0.5. This is a specific case we must verify using the model equation. This statement addresses the model's input variables. We need to consider if the model depends only on monthly spending, or other factors too. This is the single feature our logistic regression model uses to predict customer churn. It's the amount a customer spends each month. We'll use this amount to calculate the probability of churn. This is what the model outputs. A number between 0 and 1 representing the likelihood that a customer will churn. A higher number means a higher probability of churn. For example, a churn probability of 0.8 means there's an 80% chance the customer will churn. This is a type of statistical model I'm using to predict churn. It calculates the probability of an event, here, churn, based on input features, here, monthly spending. The equation involves coefficients, which weigh the importance of each feature. I'll explain those next. I'm asking you to interpret the model's output, so I'll test your understanding of how these coefficients impact the prediction of churn probability. Think of the intercept and coefficient as ingredients to a mathematical recipe for calculating the churn probability. This describes what I'm working with. I'm building a model that uses the logistic regression method to predict whether a customer is going to stop using our service, churn. This is the intercept of the logistic regression model. It represents the log odds of churning when monthly spending is 0. Think of it as the base level of churn probability. This is the coefficient for monthly spending. It tells me how much the log odds of churning change for every $1 increase in monthly spending. A positive coefficient means that higher spending is associated with a greater likelihood of churning. This question asks us to determine which statements accurately reflect how the model, using the intercept and coefficient of monthly spending, predicts churn based on customer spending data. This is the starting point for calculating the log odds of customer churn. Before considering monthly spending, the log odds of churn are -2.5. I will use this value in the logistic regression equation. This statement tests my understanding of how the model predicts churn probability based on different monthly spending levels. I'll need to plug the spending values into the logistic regression equation to compare probabilities. This statement checks whether I correctly interpret the meaning of the positive coefficient for monthly spending on the probability of churn. A positive coefficient indicates an increase in the log odds of churn. I'll need to determine if that results in a decreased probability. This statement asks if I can use the model to predict if the probability of churn exceeds a specific threshold, 0.5, for a particular monthly spending amount. I need to calculate this probability to verify this statement. This statement tests my understanding of the limitations of the given model and the broader context of logistic regression. Although this particular model only uses monthly spending, I need to remember that real-world logistic regression models often incorporate multiple features. This indicates the type of model I'm working with. Logistic regression, which predicts the probability of an event, churn in this case, based on input features. This is a very common machine learning model. This model is designed to predict customer churn. This is the intercept term in the logistic regression equation. I think of it as the baseline probability of churn when monthly spending is 0. It's a constant value that shifts the entire prediction curve up or down. This is the coefficient for monthly spending. It tells me how much the log odds of churn change for each $1 increase in monthly spending. A positive coefficient means higher spending is associated with a higher probability of churn. This is the core question. I need to use the provided intercept and coefficient, along with the logistic regression equation, to determine which statements accurately reflect the model's behavior. Remember, the equation is probability of churn equals 1 plus e caret, intercept plus coefficient asterisk monthly spending. This statement is incorrect. Since the coefficient for monthly spending, 0.1, is positive, increasing monthly spending increases the log odds, and therefore the probability of churn. I can show this using the equation. Let's check this. Plugging $100 into the logistic regression equation with the provided values yields a probability above 0.5, so this statement is true. That means the model predicts that a customer spending $100 is more likely to churn than not. This statement is tricky. The provided model only uses monthly spending. However, logistic regression models can, and often do, include many more factors. So while true for this specific simplified model, it's not generally true for logistic regression models in general. It's a bit of a trap answer. I will plug $50 and $20 into the equation separately. The result shows that the probability of churn is indeed higher for the customer spending $50, making this statement true. The output of the logistic regression model will be a probability between 0 and 1, representing the likelihood that a customer will churn. The higher the probability, the more likely it is that the customer will churn. Simple, right? I see the intercept for this logistic regression model as -2.5. This is the baseline prediction when monthly spending is 0. It's like the starting point on a graph. This is the coefficient for monthly spending. It tells me how much the log odds of churning change for every $1 increase in monthly spending. A positive coefficient means more spending is linked to a higher chance of churning. This is the logistic regression equation. Let's break it down. We take the intercept, -2.5, add the coefficient, 0.1, times the monthly spending, then stick it inside the exponential function, express. We flip the sign, add 1, then take the reciprocal, 1, value. That gives us the probability of a customer churning, P, churn equals 1. It's basically calculating the probability using the model's parameters. It's all about combining the intercept and coefficient with customer data to get the chance of churning.